discolor. And if you fill them with plastic, then it doesn't. It'll last forever. You can cut on a granite, and you're not going to cut it, because no knife is as hard as a granite. You can clean on it, you can wipe it clean, and some of the granites, they coat it for a long time. The one we had in our previous kitchen, they said to coat it every year to put a fresh coating of this goop that they sell you for it, and it worked very well. The advantages of getting a gneiss instead of a granite is because in a gneiss you get this compression in there. They tend to squeeze out more of the space, so they tend to be even denser. They have less of this pore space in them than a regular granite, even though the amount of pore space in a granite is essentially close to zero. But there is that little bit, and you tend to have fewer of the little cracks and things like that in it. So in our house, both of our, quote, granites actually were low-grade gneisses that squeezed the. But what are the hazards? There's a big flap recently. Oh, you shouldn't use granite, it's dangerous. Well, let's take a look at what it is. The big factor was that somebody found a granite that had a fair amount of uranium in it, and when they measured the amount of radioactivity on this, they got a deflection on a meter. Now, is this bad or is this not bad? Let's take a look. What is radon? Well, radon is an inert chemically gas that's produced as part of the radioactive decay chain of uranium. There's two uraniums that are in the chain, both produce a radon. The radon that is a factor, that's a problem, is the radon that's produced from the decay of uranium-238. Uranium-238 is the most abundant isotope of uranium, and most of the uranium that you find in granites or in anything else is uranium-238. The uranium-235 is much more active. It has a much shorter half-life. That's what the Iranians and others are trying to extract to make atom bombs out of. You can't make atom bombs out of 238 without a lot more work than that. But anyhow, the radon that's produced here is radioactive itself. I don't know how many of you are familiar with the decay scheme of uranium, but essentially you start out with uranium-238, and you go to thoron, thorium, to palladium, and so on, not palladium, proactinium, and so on down, a whole series of different elements, till you eventually end up with lead-206. But what we're interested in is in the radon, and the next, this is radon-222, which is the